Imagine rewinding the entire universe. Every galaxy, every star, every planet, and every atom begins moving closer together. Galaxy clusters shrink, the vast distances between them disappear, and eventually everything we know is compressed into an unimaginably hot and dense state. According to modern cosmology, this is where the story of our universe begins. Around 13.8 billion years ago, the universe entered a period of rapid expansion known as the Big Bang. Despite its name, it was not an explosion into empty space. Instead, space itself began expanding, carrying matter and energy with it. Time, distance, and the physical laws that govern the cosmos all evolved as the universe grew larger. In the earliest fraction of a second, temperatures were so extreme that ordinary matter could not exist. The universe was filled with an energetic mixture of fundamental particles moving at incredible speeds. As expansion continued, temperatures gradually dropped, allowing these particles to combine into protons and neutrons. Within a few minutes, the first atomic nuclei formed. Hundreds of thousands of years later, electrons joined those nuclei to create the first hydrogen and helium atoms. For the first time, light could travel freely across space, leaving behind a faint glow that still fills the universe today. Astronomers call this ancient light the cosmic microwave background. It is one of the strongest pieces of evidence supporting the Big Bang model because it represents a snapshot of the universe when it was only about 380,000 years old. Even today, highly sensitive instruments can detect this faint radiation coming from every direction in space. Another major clue comes from the expansion of the universe itself. In the early 20th century, astronomers discovered that distant galaxies are moving away from us. Even more remarkable, the farther away a galaxy is, the faster it appears to recede. This relationship revealed that the universe is expanding in every direction. As galaxies move apart, the light they emit stretches along with expanding space. This shifts the light toward longer, redder wavelengths in a phenomenon called redshift. By measuring this stretching, astronomers can estimate both the distance to galaxies and how the universe has changed over billions of years. Yet the story becomes even more surprising. Scientists expected gravity to slow cosmic expansion over time. Instead, observations revealed that expansion is accelerating. Something unknown appears to be pushing galaxies apart faster as time passes. This mysterious effect is commonly attributed to dark energy. Although dark energy cannot be observed directly, measurements suggest it makes up most of the universe's total energy content. Its true nature remains one of the greatest unsolved problems in modern physics. Another invisible component, dark matter, presents an equally fascinating mystery. Unlike ordinary matter, dark matter neither emits nor reflects light. Scientists detect it indirectly through its gravitational influence on galaxies and galaxy clusters. Without dark matter, many galaxies would not rotate in the way astronomers observe today, and the large-scale structure of the universe would look very different. Together, dark matter and dark energy dominate the cosmos, while the stars, planets, and galaxies we can actually see make up only a small fraction of everything that exists. These discoveries remind us that the visible universe is only part of a much larger picture. Over the past century, astronomers have built increasingly powerful telescopes to investigate these mysteries. Each new generation has expanded humanity's understanding of the cosmos, revealing that the universe is older, larger, and more complex than anyone once imagined. But perhaps the greatest discoveries are only beginning. Because today, a remarkable observatory is allowing scientists to look farther into cosmic history than ever before. The James Webb Space Telescope is giving researchers an unprecedented view of the earliest galaxies, helping them investigate how the first stars and galaxies emerged after the universe began. And what Webb is finding may reshape our understanding of the young cosmos. For decades, astronomers believed they had a reliable picture of how the young universe evolved. According to the Standard Model, the first galaxies should have been small, irregular collections of stars that slowly merged over billions of years to form the massive galaxies we see today. The uploaded source explains that James Webb's observations have challenged some expectations about the appearance and maturity of early galaxies while still supporting the overall Big Bang framework. The James Webb Space Telescope was built to investigate this early era with greater precision than any previous observatory. Unlike visible light telescopes, Webb observes mainly in infrared light. This is essential because the light from the earliest galaxies has been stretched to longer wavelengths during its journey across the expanding universe. By detecting that ancient infrared light, Webb allows astronomers to observe galaxies that formed when the universe was still in its infancy. Every deep field image captured by Webb is like opening a window into the distant past. Within a tiny patch of sky, the telescope reveals thousands of galaxies, each representing a different moment in cosmic history. Some appear as they existed more than 13 billion years ago, only a few 100 million years after the universe began expanding. These observations are helping scientists answer one of astronomy's biggest questions. How did the first galaxies form so quickly? Some of Webb's earliest images revealed galaxies that appeared brighter, more massive, and better organized than many astronomers expected. Instead of finding only small collections of young stars, researchers discovered systems that seemed to have already undergone significant growth. This does not mean the Big Bang theory is wrong. Instead, it suggests that certain stages of galaxy formation may have happened faster or more efficiently than earlier computer models predicted. Scientists are now exploring several possible explanations. Perhaps the earliest stars formed in enormous numbers, enriching young galaxies with heavier elements much sooner than expected. Perhaps clouds of gas collapsed more rapidly under gravity, allowing galaxies to build their structures in a relatively short period. Or perhaps existing models of galaxy evolution simply need refinement as new observations become available. This is how science progresses. New evidence does not automatically replace established theories. Instead, it helps improve them by revealing details that earlier observations could not detect. Another major area of research involves an idea known as cosmic inflation. According to this hypothesis, the universe experienced an incredibly brief period of extremely rapid expansion almost immediately after the Big Bang. During this tiny fraction of a second, space itself expanded enormously, smoothing out the young universe while leaving behind tiny fluctuations in density. Those tiny variations eventually became the seeds from which galaxies, galaxy clusters, and the vast cosmic web developed over billions of years. Understanding inflation could help scientists connect the physics of the earliest universe with the large-scale structure we observe today. Yet many questions remain unanswered. What triggered inflation? Why did it stop? Could similar processes occur elsewhere in ways we do not yet understand? The James Webb Space Telescope was not designed to answer every one of these mysteries directly, but its observations provide critical evidence that helps astronomers test competing ideas. Every distant galaxy Webb observes becomes another piece of an enormous cosmic puzzle. As researchers continue analyzing its data, they are improving computer simulations, refining theories of galaxy formation, and learning more about the conditions that existed shortly after the universe began. Perhaps the most remarkable realization is how closely our own existence is connected to this ancient history. The hydrogen atoms in our bodies were created during the universe's earliest moments. Heavier elements such as carbon, oxygen, silicon, and iron were forged inside generations of stars that lived and died billions of years before our solar system formed. In a very real sense, every person on Earth is connected to the history of the cosmos. The story of the universe is also the story of us. And that story is still being written. Future observations from James Webb, together with the next generation of space telescopes and ground-based observatories, will continue exploring deeper into cosmic history than ever before. Each new discovery may answer one question while raising several more. That is the beauty of scientific exploration. The universe continues to surprise us, not because it breaks the laws of physics, but because it is more intricate and more fascinating than we once imagined. With every new observation, humanity moves one step closer to understanding how everything began, and how the remarkable universe we call home came to exist.